courses which are very much software oriented or can be categorized as computer science program, and courses which are very much related to hardware can be called as computer engineering courses. So any computer science course starts with mathematics courses which are theoretical, and they are also very much connected to the software, so they can be placed in the top left quadrant, and those courses are discrete structures, linear algebra, probability and calculus. The corresponding textbooks and what we study internally will be discussed in later in this video. And we have programming languages like Python, Java, C++, and assembly. But these courses, some of the courses are high level languages and some are low level languages, and some are more comfortable or friendly with the hardware, and some are more high level, and it is far from the machine code. Courses like the programming languages like assembly are more closer to the hardware, where we code at an instruction level, whereas programming languages like Python are more high level, and they are more far from the hardware. The C++ are also very much used for hardware level programming, especially in courses like embedded, where C is very much used, and programming languages like Java and Kotlin are very much used in the web and mobile app development. So then we have the core theoretical courses in computer science like algorithms, data structures, theory of computation, relational algebra, databases. All those things comes under the theoretical and software related courses. We have AI related courses like machine learning, deep learning, generative AI, and the traditional knowledge representation and reasoning, AI search algorithms. All those comes under the computer science, and they are more of theoretical and software oriented. And we have practical oriented courses. So here we can see the y-axis, the bottom ones are practical courses and the top ones are theoretical. So in the bottom, top left bottom, we have more of practical oriented computer science courses, like databases. We study SQL, where we write queries and do all the CRUD operations. And we also have a non-relational databases or NoSQL. The famous one is MongoDB. And we have cloud computing technologies, where we try to do all the computation, storage, everything in cloud. And some of the famous cloud hosting services are from AWS, GCP, and Azure. We have big data, which is also a distributed computing and distributed storage, where technologies like Hadoop and Spark, PySpark are very famous. And we have AI, which can be implemented using frameworks like TensorFlow and PyTorch. We have data science libraries like data science frameworks like Power BI and Tableau, and we also have Python libraries for data science and ML like NumPy, Pandas, sklearn, etc. The traditional software development, like the web development, includes both front end and back end. Those are also more of practical oriented, and that can be developed using the front end technologies like HTML, CSS, and JavaScript, and the more recent JavaScript frameworks like React.js and AngularJS. And the backend technologies can be developed using any of the frameworks like PHP, Django, Spring Boot, and Node.js. And mobile app development can be done using Android or the cross-platform development technologies like React Native and Flutter, a Python-based framework like Eve, and iOS apps. So these are more of practical and software-oriented courses which we study as part of computer science. And coming to the hardware oriented courses and theoretical in nature, we study courses like operating systems, computer organization and architecture, digital logic, microprocessor, and also the assembly level assembly language programming, usually studied as part of microprocessor course. So in digital logic, we study various digital representation number systems like binary, octal, hexadecimal, and how do uh, we also study about various logic gates like OR and XOR, NOR, complement, all those. And we try to learn techniques to simplify the Boolean expressions. And we have various concepts like combinational and sequential circuits. How do we store data, bits, what is the hardware involved in it? All those things are studied in digital logic. Microprocessor involves much more, and it involves complete technology of what all processor includes. So it is very much hardware oriented, and it is also theoretical, somewhat theoretical, but a lot practicals are also can be done using assembly language programming. So we have courses like computer networks, embedded systems, IoT, microcontrollers, which are more of hardware oriented and also practical. So computer networks, I have placed it very close to the center because it involves both hardware like working with routers, switches, all those things. But when we study computer networks, we study the 7 layers of OSI layers and different network protocols and various concepts related to networking. So it is somewhat closer to software and hardware. So it is placed close to the center. And we have embedded systems, IoT, microcontroller, which are very much hardware related, and robotics, which is also very much hardware related. So in this way, we can broadly categorize the courses of computer science as computer science and computer engineering. Computer engineering deals with courses which are more hardware oriented, and computer science are the courses which are software and also linked to domains like AI, data science. So we have one courses like security, which are once again involves security at various levels. It can be a software security, hardware security. So that's why it is placed once again at the closer to center. And we have gaming. Once again, the gaming is usually done using a low level language like C++, and it also relies on what hardware we are developing. And because the latency, all those factors are very much based upon what type of hardware it is being rendered on. So these are the courses which are present in computer science. And we also have the traditional software engineering. We study various technologies, various methods of software development. And we have courses like DBMS, where we also study the theoretical things. We study practicals like SQL and NoSQL, but all the theoretical concepts are very much important in computer science. And also basic electrical and electronics is not a prerequisite, but it is essential to understand, and that falls into the category of hardware.